Hi guys, today we're going to go over some of our equipment in the lab. This video will be specifically on our 3D printers. So we have a couple of Lulzbot TAS6s here. We have a new Markforged printer that I don't have set up yet. And at home at the moment I have a Prusa that we do. These are FDM style printers. That's fused deposit material. They print by laying down a small or a thin layer of material and then just layer it up. If you were to take a three-dimensional object and you were to slice this into paper thin slices and then take each one of those and draw it up and then layer them back up, that's essentially what this is doing. We usually work with PLA, that's a polylactic acid. That's our filament here. It's what looks like weed whacker cord feeding into our 3D printer. We can print with a variety of materials on these 3D printers though. PETG, which is very similar to what a water bottle is made out of, the reusable or the disposable recyclable ones. It has glycerin added to it to make it more stable. We can print with ABS. We don't much in here at the moment because ABS stinks and we have no way to vent it. I have nylon for this that we can print with. We have for the Prusa at the moment, we'll get some for this, we have a flexible filament. These particular printers, we have a couple of extra things we can add on to it. We have a head that prints larger than normal, so we can build big things fast. It's not very precise though, so it doesn't make pretty parts. We also have a head that can print in 2 different materials at once, and we can do things like this. This cool little gear was printed all at once. A couple other things that we've done. We have a student who built part of a shelf bracket here, and some of this was laser cut. We'll get to that in a little bit. Fighting with stuff off the screen. We had a couple of students design this cool little Frankenstein head. They put LEDs inside and it glows. This was printed in 3 parts so that it all goes together, and we just used a pen for the hinge. Not super clean, but we have ways to clean it up. One thing about 3D printing is it usually requires some post-processing, or essentially you've got to sand it and work with it when it's done. So I wanted to show you the setups here as we boot this up. So this 3D printer is pretty basic. We just fire it up and it takes a moment to boot. I'm gonna go ahead and go through this screen and go to print from SD. I've already got something on here that I'm going to print. So these are STLs, which we'll cover in a little bit, which are pre-sliced into G-code. G-code is a machine code that is largely coordinate based, that tells this part of the head, the 3D printing head, where to go. So timed out on me there. So these 3D printers are a little slow about the process of actually clicking, so you want to move to which one it is, give it a second, and then click. The 3D printer will go through a warm-up process. It'll warm up to about 140 degrees. It will then wipe the nozzle, make sure that there's not residue on the end. From there, it'll go and touch these metallic corners. And what it's doing there is essentially creating a ground circuit so it can level itself. Not all 3D printers self-level, but a lot of them do these days. It's really nice. The first layer, it's very important that the first layer is level. Otherwise your whole print gets off and then it does all sorts of wonky things. So it'll touch all those corners. In the event it doesn't touch it, there's still some stuff on there. It'll re-wipe the nozzle and come back and touch them all again. The bed itself on here is also heated, so it is heating up slowly to about 60 degrees centigrade. I think that's about 140 degrees Fahrenheit. We usually print at about 200 degrees centigrade. That's double boiling water, so don't touch the end. Right down here. There's a series of fans on the side of the print head here. These fans that are on either side are to cool the part as it goes. You can see it's starting to go through its alignment process. I forgot to mention there's a button here that it goes and it levels the Z height with that. So the up and down. Anyways, there's another fan up front that pretty much always runs. This one is to keep the heater block itself cool, which sounds strange, but we want the very end of our print nozzle to be at temperature, but above that we want to cool it down quickly so that we don't end up with a whole bunch of melted plastic. We've only got a little bit of melted plastic right at the end. So I'm going to let this go ahead and go through its warm-up process here. I'm just going to wipe. We usually will print with, essentially what that does is it does an extra layer or a line or two around the outside of your part. That's to prime the nozzle. That way we don't end up with, we don't start our print without having all the plastic there. Very important to have the nozzle primed. That your first layer is the most important layer of an entire print. If it doesn't work right, then none of it will work right. It's what is required to stick to the part. The part I'm printing right now is very simple, doesn't need anything special, but some prints, if they print at interesting angles, require something called support. Support is just a sacrifice material that you print that gets wiped off at the end, or broken off at the end. Sometimes that's easy, sometimes that's time consuming, part of that post-processing. But it allows us to print shapes that otherwise we couldn't do. 3D printer, because it's printing layer by layer, can't really print anything over about 45 degrees. Looks like it got wiped. It's working right. Okay. Sometimes it can be a little feisty. Now it's going to go to the other corner, and it's going to do all 4 corners. Anyways, sometimes we print with supports which you break off. We can't really print things over a 45 degree overhang. There's nothing for the filament to stick to, so we just print a little something that we break off. In our lab, we have just started working with a recycling system, so we can recycle our PLA back into filament, so it's not really a waste besides energy and time. As you can see, it's just finishing up. I'm going to let it finish up this last little bit here. And once it's done there, we're up to about 160 degrees. It's going to warm up that last little bit. So we've got to warm up. Looks like we're going to print at 210 degrees now. It's fairly quick to warm up, but this does take a minute or two. For small prints, uncomplicated prints, you can just print directly on the glass. This is actually a borosilicate. It's like a Pyrex. But for complicated things, we usually put a little bit of glue stick down. It just helps things stick. This becomes important as you create taller parts, especially if they have a lot of support and other things. So I'm going to let this get up to the last bit of temperature. We'll watch it start and then we'll end the video there. 198, 200. As you can see, it goes pretty quick. It's going to come down. And right now it's just retracting a little bit of the filament out so that it's not oozing. Oozing is a problematic thing. And hopefully you can see that. We're starting to lay down a little bit of filament. And essentially this will just go around and do layer by layer. We'll cover slicing in a different video. Slicing is the actual process of taking it, your STL, and getting it ready for 3D printing, converting it into G-code. This particular part takes about 15 minutes. I won't bother you with the full video, but there we go.